Hello, my name is Hakon and welcome back to my channel and another episode in my ongoing series where I talk a little bit about my Synth DIY project, where the aim is to create extra modules to expand the possibilities of my phenol synthesizers and put them into my new phenol synth stand. Just to recap a little bit, a few episodes ago, I talked about how I have decided to, or was it last episode? I can't remember now. Anyway, recently I talked about how I had to scrap the MIDI to CV interface because it was not reliable enough. If something isn't reliable, you just have to scrap it. And also I talked about how I was going back to wanting to use a wood front panel to build the modules on, as opposed to the cardboard, which is too wobbly. So that's fine. And then I made the wood front panel and I've drilled the holes and I've started putting in components, and I remember why I wanted to get away from wood in the first place. It splinters quite easily. And of course, in this case, because of this is reclaimed pallet wood, the nail holes did actually cause some problems during drilling, and some of the holes are consequently off. That's still, it makes that doable, but there's another problem as well. First, well, it's not very flexible if I want to change something. And also, there's another thing as well. If you look at the potentiometers I've got, so there's these panel mount ones here, which are the cheap and cheerful ones, which are not very good quality, but they do the job. Just make sure you test them before you actually solder them in. And I have some better quality ones here, which are PCB mount. Now, the thing is that the panel mount ones are not suited for anything that is as thick as this panel. And the PCB mount ones requires me to actually solder these onto PCB or attach them in some other way, which is going to be quite fiddly, possible but fiddly. And so the easiest thing to do would have been to get some new tall panel mount, extra long shaft panel mount potentiometers, but I had decided already I wasn't going to get any more components. I wanted to use what I have. So then I actually went back to an idea I had before I started on the wood panel. I really like the wood panel, by the way, but it's a shame it didn't work out so much. And that is to actually create or use as a front panel these Vero boards. So a Vero board or a strip board is, I'm not sure if you can see that, but there are these vertical lines of copper on one side, which means that anything that is connected to the same column here is connected together unless you actually remove part of that path. So, which makes it a lot easier to wire things up than on a board that only has soldering points but no strip connections. And I thought I could use this as my front panel. This additionally has the advantage of being about the right size. As you can see, it is almost the same height as the wood panel now. This is almost the same height as Eurorack panels. In fact, I think you could actually put in a screw hole the right place here and mount this on a Eurorack rail. I'm thinking I might do a custom rail for it instead though, but I haven't decided yet, because if I use the Eurorack rail, which I do have, that gives me the advantage that I can add Eurorack modules later if I want to. Now, and what I was thinking was I'll just, of course that's going to be the back now, which is a bit of a shame because it looks so nice. So the components would then be soldered on this side, and I'll just solder it there, and then it would just stand proud there of the PCB, and not PCB really, but a Vero board, and it would actually look quite nice. It would look like a piece of electronics in addition to being a user interface for a sequencer, and of course the chip would also be visible on the front. Now, a friend of mine, of course, pointed out when I was sort of showing him my DIY electronics projects, the first thing he thought of when I showed him my previous version with the cardboard was that it's not shielded. You should use aluminium panels. And my response was that I want interference, because if I get interference and noise in my modules, that actually suits the sound and the style of music. So for me, that is not a problem. It's actually a good thing if this is not shielded. So that's not going to be a problem. So that means using this, it'll be very easy for me to use these PCB mount potentiometers, which I really like, by the way. They are quality tall trimmer pots, really, but they are very comfortable to use, very accurate, and nice and soft. Good resistance there. Now, another thing I wanted to do, as I mentioned last time, was to use my super high quality switch to switch the number of steps on my sequencer. Again, it would take up almost the whole panel, and I was thinking, is it possible for me to fit this sequencer and the interface for the Zoya to connect to it on a single panel? And the answer is yes, it is, if I go back to my original idea of using only 5 steps of the sequencer. So the 4017 chip, if you know, is known as a decade counter, and that is because it can do up to 10 steps. I like the idea of a 5-step sequencer for my style of sort of West Coast experimental, modular, go with the flow kind of music that I usually make on the Phenol. And so 10 steps is almost on the verge of getting a little bit too musical for me. So I think I'd rather have 2 5-step sequencers than 1 10-step sequencer, if you know what I mean. So, and also one of my favorite instruments, the Buchla Music Easel, has 5-step voltage sequencer, just like this one. Well, not just like this one, but a similar concept. And so I find that quite inspiring to just have 5 steps. And also it's nice to have an odd number as well, I think. So I'm going to go back to 5 steps, which will fit on here. I'm going to show you in a moment. I'm going to show you the mock-up I've done for the design of it. So I will have these. So I'll have an input from the Zoya, and then I will have output and input to the Zoya, of course, so I can connect it to other things on the. I'm going to show you. I'll talk about that when I get to the PCB layout afterwards. Okay, so another thing, yes, I did mention I wanted to use this switch, but it's going to take up too much space. So I wanted to use just a single panel. And then I thought, okay, so I need a smaller switch. Of course, you get switches this kind of size. But then I would have to get a new component, and I'd wanted to avoid that. So I remembered that lying around in my loft, I had these radio buttons from a sort of passive channel selector device that I'm not using because it was too noisy. But I realized that this, of course, looks nice, has a nice tactility to it, and I can remove a few of these switches and create. I just need 6 of them, so I need off 1, 2, 3, 4, 5 active steps of the sequencer. Remove 3 or these 2 at the end, and that actually fits nicely within the length of the Vero board, and then I just need to drill holes for it, of course. And that's going to be a slightly tricky drilling project because these are not the same pitch as the board. So I'll need to make a drill guide first, and then I'll need to drill those. So those are going to be my selection switches for the number of steps that are going to be played, as well as sequencer off. Right, I'm just going to show you now, I think, my design, or my so far my current design, I should say. I keep changing it every single day. Another thing I wanted to perhaps integrate was to make a panel here where I also have a this is not a VU meter, but it's a galvanometer. Might look really cool just to have it there. I was also thinking maybe I should just make actually an LED VU meter, which is not a tricky thing to make, and make that as part of another panel, perhaps. But I do have room for several panels now on my rack. Now, I'll just swap to my screen in a moment, and I'll show you what I've been doing so far. Right, so here we are on my screen, and I've got the panel layout, the current panel layout, where everything I need here, ins, outs, and the sequencer itself is on one Vero board. Quite a compact design. Just to start from the left here, which is the ins and outs, I could say, or the main input to the board. So let's start from the lower left corner here. We have an input there, which is if I want to connect the phenol to trigger the sequencer, this is where I would insert the jack from the phenol, is in the lower left corner here. Then there is an attenuator, which attenuates the input. Then we have a 1/4-inch jack, which is the connection to the Zoya. And of course, that is both an input, an output, and a ground connection. So the ground would then be connected to all the other grounds. And that is also how the Zoya would ground to the phenols, which is quite useful. Then we have here the input to the Zoya. So if you want to send a signal back to the Zoya from the phenol, this is here. And then we have an attenuator for that. And then we have the output from the Zoya with a light, with an LED light and an attenuator. And the reason I have a light there is because I want to indicate whether the Zoya now sends its input to this jack or to the sequencer. I didn't have to do that, but it fits on the board. What I could have done is to only have a Zoya interface and then have to connect a cable from the Zoya output here to the sequencer input. But I chose to do it this way because that's my initial idea. So there's going to be no cabling necessary to connect the Zoya to the sequencer. That's going to be direct. And this switch down here, and of course color-coded now with a white light as well, is indicating whether when this is on, it means that the output here is on, and when it's off, that means that the sequencer is connected directly to the Zoya. Okay. And both the direct connection from the Zoya to the sequencer and from the banana jack here to the sequencer are both going into the same place via this attenuator here. It should also be possible then to connect both at the same time, which could create some interesting effects. Then we have the row of radio buttons here. Radio buttons, of course, because only one can be pressed at a time. And then all those buttons are actually quite usefully, by the way. They're all double pole, which means I can control two things with them, and I'll get back to that. So they select the number of steps that are being played. One of the buttons is going to be sequencer off, and the other ones are going to be 1, 2, 3, 4, or 5 steps played before it restarts. Then here we have the individual step outputs, I should say, or controls. So we have step on-off switch. We have an LED which indicates, which lights up when the step is being played. we have an attenuator for the output. And this is because the voltage coming in to the 4017 is generally, I will probably play a steady voltage like a gate input, but I may use variable voltages, see how that behaves. But to start with, if I use a steady voltage every time, every pulse, then the output voltage will be controlled by these controls instead of by the input. So that means that I can adjust the pitches, for example, or the control voltage values from these attenuators. And then the attenuators go two places. They go to the outputs, or they go to this diode. And the idea with the diode is, of course, that it allows me to create also a single sequencer output down here, which all the different steps go to their individual outputs, but they also all route through these diodes into this output down here, which is possible to switch off. And of course, when that is on, this is meant to be a green LED there, color coded again, green, green, green. And that is I still haven't checked actually whether you can run individual outputs and the whole sequence at the same time and what happens. At the moment, of course, I will make room for this switch and I'll see how I wire it up when I get to it, if that is going to be an issue, or whether interesting things can happen if I actually leave the connection on in both cases, but use a switch to create an exclusive output for the whole sequence output. Here, of course, we follow the 4017 chip itself here on a socket. Right, and then we have these resistors here, which of course are for the LEDs to ground. Now, of course, I didn't need to put them here, and I don't need one per LED. I can just use one common one for all of them. But at the moment, it looks more aesthetically pleasing to me to have these visible on the front panel and also to have one for each LED. I'm also not in two minds at the moment about whether to have visible wiring on the front. I may do that. I've done some, you can see some faint colors in the back here. Those are wires that I've intended to put on the front. Now, for my original designs for this, I was thinking of ways of showing the wires coming off the 4017 as well, but eventually I decided against that to make better use of the space. At least when I realized that I could do all this on one panel, because to start with, I did actually start with two panels, and then I narrowed it down to one eventually when I decided to go with not using the huge switch and instead using this row of radio buttons here. So that's where I'm at the moment. This will not be too complicated to do. Now, there will be some drilling to do here, but of course, drilling in these panels is very easy. It's a very forgiving material compared to wood. It is a kind of plasticky kind of material. And of course, all the drilling is going to be on expansions of holes already there, except for this button row here, which is not the same pitch as the rest. This button row is metric, the rest is imperial pitch. So what I will need to do is to, and also in order to actually get the buttons to have the right height, I'm also going to have to create a little bit of something in between the board and the buttons to actually make them lower them down a bit. And of course, whatever I use for that, which probably will be wood, is going to then be also sort of a spacer as well as a drill guide for drilling the PCB when I get to that. Now, all these extra LEDs, now the thing is that I'm not going to run these indicator LEDs on the same circuit as the rest. Now, there are two ways I can go about doing that. I could take the power from somewhere on the phenol. I could sort of dedicate one envelope, for instance, as an LED driver for all of them, and just use that. That is a possibility. The second possibility is to use an external power source plugged into the back, which then drives all these additional indicator LEDs, so they all have uniform brightness. I may actually do some way of connecting the power from the from the phenol itself, because the fun thing then is I can actually vary the intensity, brightness, etc., and of these indicators. Now, so this indicator up here, again, that is to show that the Zoya sends its output to the output jack rather than to the sequencer. This one down here is to indicate that that state is on, so these two white ones will come on at the same time. The green one here is to indicate that the sequencer is in sequencer mode and not in individual step mode. These 6 ones here is going to show whether it's off and then which number of steps are on. And then these ones are the big ones here are going to be, so this is 5mm LEDs and these small ones are 3mm LEDs. And these big ones are going to light up when each step is active. So that is my design at the moment, and I'm quite liking this. I think I've refined it quite a bit now, and I'm getting quite happy with it. It's very close to me starting drilling, actually. So that's it for the moment, and I hope you enjoyed that, and I'll be looking forward to my next episode, where I'll probably will have something more to show you, hopefully something physical, and I hope you enjoyed watching this series so far. Goodbye for now. Bye-bye.